I'm going to be working on issue number 9 for the Kaiju Engine. This is setting up mouse input. So this will be the first input that we're doing, just because it's going to be a lot easier than, say, the keyboard or controller, stylus, touch, all that other stuff. It's kind of the most primitive one we can deal with. So I'm going to create a new package for these, and I'm going to call HID for Human Interface Devices. And I just don't want to write out human interface devices. It's just a lot of words. So mouse.go. It's going to go in here, package HID. So this one is just going to be set up and ready for the events. Depending on how difficult the events are going to be for us, we may we're probably going to hook up the actually invoking the events in another issue, just because where we're going to be holding the mouse, keyboard, controller, whatever, all these human interface devices, is probably going to be in the platform, or maybe it's in the host. Not sure yet. So we'll start off with just constructing a primitive, fully functional mouse code that is abstract from the system. So we're going to create a mouse button left, and we're going to set that to iota, maybe. Oh, no. We're going to have that set to something called the internal mouse button left. And this will be per platform. And these can be hidden behind build constraint. So for now, const to do remove these once we have the platform stuff. So I'm going to have just internal mouse left is equal to 0. I'm going to set them all to 0. Middle, right. Okay. So put those in there. And we'll work with the X buttons on the mouse, the two side buttons, a little later. So we'll just set up mouse button last is equal to 5. Mouse invalid is equal to -1. Mouse release is equal to 0. Mouse press is equal to 1. Repeat, and mouse button state invalid is equal to -1. Okay, so we have our constant set up. We're going to set up our structure. Type mouse struct. We're going to have an X and a Y. And we're going to set these to float 32. They don't really need to be any larger than that. Whoops. We're not going to have a screen. I mean, we could have a screen the size of, a few planets, depending on how micro we want to get. But we'll just do float 32 for now, just to be reasonable. So this is going to be the screen X and screen Y. So rather than calculating those all the time, we can just have them pre-existing. And this is going to be the center X and center Y. Scroll X, scroll Y, button states, and this is going to be mouse last, and set this to an int. Moved, bool, button changed, bool. These probably should be helper functions. Scroll pending, bool. So let's make these button changed and moved into package members, private package members. So with that, we'll create new mouse function, new mouse, and this will create a pointer to a mouse. M is equal to mouse. And we just make that the address of the mouse, return M, and for I is equal to 0, I is less than mouse button last, and we're going to set it to mouse invalid, mouse button state invalid. Cool. And this is just an integer. We can change these buttons states into types, but I'm going to leave it like that. So let's create a moved function, func m mouse moved bool return. Mouse moved, button changed as well. Okay. So now that we have those two guys, we'll go to our func m mouse end update. So this is the end update we talked about previously when we were setting up the host. So for I is equal to 0, I is less than mouse button last, I plus plus. If m dot button states I is equal to mouse release, well then the state is now going to become mouse invalid. Mouse button state invalid. Else if m dot button states is equal to pressed, it's going to become repeat, and we're going to say m dot button changed is true. So m dot scroll x 0.0, m dot scroll y, m dot moved is false. So now we're going to say func m mouse move. So this is going to allow us to move it externally. X, Y, window width. Remember, we're going to do the SX and SY, screen X and screen Y. So if m.x is not equal to x, or this should be an int. Load 32. m.y is not equal to y. Let's say m.x is equal to x. Y is equal to y. We're going to do screen x is going to be equal to x, and screen y is going to be equal to window height minus y. And then mcx is going to be x minus window width divided by 2. And then cy is going to be the window height divided by 2 minus y, and moved is going to be true. So now we need functions for setting buttons down. Func m mouse set down index int if m.button states index is not equal to mouse press. The button state equals mouse press and changed is true. So now we have a set up, which is going to be if it's not release, set release, change is true. Func m mouse pressed index int bool. We're going to say if the index is greater than the mouse button last, we're going to return false. Otherwise, we're going to return that it's equal to pressed. And for released, I'm going to have the same thing. And now we also want one for, instead of down, I'm going to call it held. And that's also the same thing. So held is going to be if it is not press and repeat, we're just going to do repeat. Just to make those a little more explicit. We can do manual checks otherwise. Mouse, button state, index, int. We're going to say if index is greater than the last, we're going to return an invalid state. Otherwise, we are going to return the state of the button. M mouse scrolled bool, and this doesn't need to be a pointer, we're not altering it. Either does this one, or this one, or this one, or this one. Set up does, set down does, move does, end update. Okay. Scrolled is going to be return matrix.approx. Well, this is just a float approximation. We don't have a helper function. I thought we made one in there. We don't. But we're going to basically say if m.scrollY the absolute value. This is a float 32 also, so matrix dot abs if scroll y is greater than or equal to math dot the smallest float 32. We'll do the same thing for the x. Now we're going to say func m mouse position, and we're going to return a vec2 here. So matrix.vec2. I'm going to return the mx and my. Then we're going to do the centered position. So let's take this, call it centered position. That's pretty straightforward. And then we can go down to screen position, sx and sy. We can now have a set position function. Set position. Wait a second. Move. We don't need a set position. These would be the same thing. So we need a scroll function. Did we not make one? Func m mouse scroll. And we're going to, or set scroll, sorry, set scroll. And we're going to take an x, a y, and that's going to be a float 32. Set the x and y and float 32, and then we're going to have a get function for the scrolled. I'm just going to return the x and y scroll. Cool. That's it for the mouse, and we are ready to start calling this. But while I'm here, I'm going to create the internals here. So we will make a new file called when32.go, or yeah, .go. This will be package HID. This is going to be a build. Go build Windows, and here's where we're going to cut this. Paste it there, and then of course we're going to have an x11.go. Same thing, except we're going to change this to Linux or Darwin, and we don't need all those others for now. So that will give us these guys, and then these can just become whatever internal mouse button is set by the system. You know, I paused the video and I was doing some thinking. I don't think I need that. I will keep these Win32 and X11 here though, because when we get to the keyboard, our scan codes or key codes might be different between those two. So I'm going to set this to 0, 1, and 2. And then 3 and 4 are going to be our two side buttons, X1 and X2. In fact, I can add them in. It's not going to hurt. X1, X2. That'll be 3 and 4. Cool. Nice, nice, nice. All right, I think that's going to be all we need here. And this is a short video, so perhaps we can do a little experiment here where we go into the windowing. Let's go into Win32, and we put in some stubs here for mouse move, left button down, left button up, and mouse move. So these events should actually be coming across. Let's see, mouse X, mouse Y, and we have the event. So all we need to do is figure out what these cases are here for the message switch, and then we can match those numbers up inside of our window go code, or not window code, our Win32 go code, where we can say func to event ID or something like that, and return an event ID or event type So we'll take in whatever the event is here. uint32 is the event type, so native type, and then we're going to return an event type. So let's go into the Win32, no, we're going into the window go code, and we're going to create a type, event type as an int, and then we can have const mouse left, mouse down, event type, mouse up, mouse left, mouse move. So let's test this out. Down, up, and move. So if we come back in here, we can now just convert whatever the native type is, switch native type, and we can also we can start with an unknown. There we go. So default case is unknown, return unknown. Cool. So now inside of our windows.h, we can figure out what these types are. We might even be able to create some kind of values we can pull out. But for now, we'll keep it simple and just hard code the numbers and come back to them a little bit later. We just want to see this thing working. So inside of the window go code, when we pull, here's where we get the event. So we can call our fancy to event type and w.evt shared memory event type. EVT type here. And what I'm going to do for now is format.printf. Hold on, let me comment this out. We're going to go to our event type and we're going to say format.println native event type. And for that, we'll need to call our event type code. Okay. So we're going to see what the mouse down and up are first. Let's make sure our thing compiles. So I'm going to bring this over, debug console. Okay. So I'm not going to move the mouse. I'm going to click down. 513, 514. Those are the numbers. And I could probably get this from the documentation. And then 512. So 12 is moved, 13 is down, 14 is up. So we can say case 512, case 513, case 514. Like I said, we'll probably export these from C, but for now, this is not down. This is mouse move. Mouse move. Left mouse move. Mouse move. Turn left mouse button down and mouse button up. I'm going to prefix these with EVT type unknown, EVT type left. I mean, I guess I could just call it event. There's not going to be other events. Less things to type. EVT left and EVT mouse move. Okay. So now we're going to convert those events to the type. And let's just give a See, this is the problem. We need to put the mouse somewhere. What holds the mouse? Is it the window that holds the mouse? Will each window have its own mouse? It's possible, especially if you want to overlap windows and click through it. That's probably something no one ever wants unless you have a transparent window. So there's some questions to be answered there. So for now, I somewhat like the idea of each window having its own mouse. I may change my mind on that. I haven't done this before. I usually just have a platform which has access to the mouse. So let's do HID mouse. Let's just see how this goes. So the window itself can have a mouse, and what we're going to do is we probably don't want to make a big old parsing function here. We'll just make a little helper function at the moment. This is all going to change and get cleaned up. We'll call it process mouse event. And we have access to the event already. So fall through this. If it's a mouse up, fall through. If it's mouse move, process mouse event. And then we can say, we can pass in the event type here. Event type. And we can have unc w window process event. We can have a general process event function. W.process event. So this is nice and small. We don't need to be doing it all in there. If it's one of these, it'll go to the process mouse event. And then, or we can just move this into the process mouse event and just always do a process mouse event. And if it's not in here, it's not going to do anything. So if it's a mouse down, we're going to say w.mouse.setDown left. If it's up, we're going to do set it up. If it's a move, we're going to say move its. We're going to say mouse dot move. I kind of like set position better because set position. Okay, set position. Doesn't want me to redo it to do that. So set position, we're going to need the mouse X and mouse Y. If we look at the event shared memory, it is just an array of bytes. But if you recall, inside of our shared memory or our shared, where is it at? Our shared header code, windowing.h, we have this structure where we have an int, and we're going to make this explicit, int32, int32t, 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 int32t. Make that explicit, which means we're going to need to include standard int in here. We have mouse X as the first int32, mouse Y as the second int32, and the mouse, which of the mouse buttons, we haven't set that up, but what we care about are these two here, mouse X and mouse Y, which are going to be the first two integers. So let's go over to our window Go, our shared memory Go, and we can probably pull out that structure straight from the binary as a pointer. It's a little jank and risky because it's built. It's kind of just messing with bytes, but who cares? We can do whatever we want. It's our code, right? We can always clean it up later. So we're going to create a structure that mirrors that event that we saw, and I'm just gonna copy this so I don't have to keep coming back here. Okay, so we have a type. We're going to call input event struct, and the key to this is we're going to have these be an exact nothing larger than the uint32. We can't have unions, unfortunately, instead of go. So we can call this something like mouse x or key. It sounds like XOR. Well, we'll call it mouse x, and we'll deal with the fallout a little later. Mouse y, and we're going to ignore the rest. It's just going to fall off the struct for now. So we have this input event. So we can say func e event mem event to mouse event. Actually, let's just do that where we have mouse event and keyboard event key and mouse x mouse y mouse event pointer and then func event mem to mouse. This stuff doesn't need to be exposed to keyboard event to keyboard event. Okay. So yeah, we're just gonna do a little more unsafe than that. So we're gonna get our unsafe pointer of, we have our event memory. We know that the first 4 bytes are reserved for our read state. The next 4 bytes are for our event. So our event type. So if we wanted to be really sneaky, we just throw in a type base event struct event type uint32. Just throw this guy in here. And then we can just skip the first 4 bytes and return that. So unsafe size of uint32, which is what we're doing here. So event type. Yeah. We cast that to a pointer, and then we're just going to unsafely, and I strongly mention unsafely, cast this out to a mouse event. It's not that bad. You do this all the time in C. So it's not that bad. It's a known quantity. A little harder to debug, but once these are set up, well, extending and adding more events is going to be a real pain, but we will deal with that as we go. Good programmers should be able to navigate these treacherous waters as they navigate many treacherous waters in their daily life. So here we can say event shared memory. We can just get me to mouse event, and then we can say me.x and me.y. And I'm going to print out format print line me and see what that looks like. Oh, and this is set position is also going to need the window width and height, which we have the window, but we haven't really saved its width and height in here. So width, height is going to be int on both of those. And when we create the window, new window, oh, we don't pass in the width and height. So we're going to say to do pass in width and height. So w dot, let's just say mouse is a new mouse. We don't need to initialize the shared memory. Width is 1280 and height is 720. Okay. And lastly, we need to pass these in, the width and height. Okay. All right, let's see what it says when I move the mouse. We crash. Let's go to our panicked go routine. And shared memory. It's fine. Title is blank. Why is it blank? There, go. C go argument has go pointer to unpinned go pointer. Oh, it's because the window now has a mouse event inside of it, or a mouse inside of it. It's a very strange one. I'm going to check that real quick. Okay, the answer is yes. Doesn't like the mouse pointer in there. This is a weird one. I'm not exactly. It's probably because it's a go routine on that guy. So if I pull that out of a go routine, it might work. I'll give that a shot. So let's bring back our mouse here. Actually, I'll just undo. Bring back our mouse, and instead of calling go to do that code, this is specific on Win32. So instead of calling go here, I presume that's why it's mad. Let's try calling func wrapper. I'm just going to make this silly. Oh wait, the shared memory is being passed in. Interesting. Let's go back to the window. HID shared memory. What happens if I put this at the top? Does it work kind of like C where the order matters sometimes here? No. Okay, I don't want to deal with the object pinning and all this other stuff right now. The mouse doesn't need to be a pointer, honestly. It is just a mouse. We go through it, we set it up, and we use it. So I'm just going to not make that a pointer. I have to figure out whatever was going on later, but here we go. So if I go to the top left corner, we've got basically a 0, 0. Hit the 0. The X is starting off on... Okay, X is working. Okay, and is that the correct... Because I want the screen space of... So screen space, the screen X and the screen Y should be the top left corner, I'm pretty sure. Since we're dealing with the bottom left corner when dealing with OpenGL and Vulkan instead of the top left corner, I think that we can just assume that these are going to be screen space coordinates. So we're going to take this screen Y and stick it up here so we get the correct values as related to how we're going to deal with Vulkan and OpenGL. So where did my window go? Set the position. So instead of printing the line here for me, we're going to print the line w.mouse.x, mouse y, and all the rest. So when we go to the top left corner, ish, we should get numbers. Yep, the middle two are the screen coordinates. The first two are going to be the coordinates for OpenGL and Vulkan, and then the last ones are going to be relative to the middle of the screen, somewhere This doesn't seem like the middle of the screen. It's the middle Y. It thinks it's over here somewhere, so that's definitely not the middle to my eyes. So let's take a look at that real quick. Oops, not the print line. Set position. So it should be x minus the window width divided by 2. And then the center y should be, since we know y is going to be the screen space, it shall be the top down. Yeah, that looks right to me. Perhaps I'm doing something wrong with Windows DPI scaling or something similar to that. So we'll just leave the code and we'll come back to resolving that a little bit later. But yeah, so this is giving us the correct correct behavior of what we want. So now that sets the mouse. We just need to set up, say, the scroll events, and we're pretty much golden here, other than the X1 and X2 buttons. And obviously, we need to set up the other states here. So I'm going to set those up real quick. We'll move mouse move to the top. We'll do middle, right, X1 and X2. And then we'll have event wheel, or event mouse wheel vertical and mouse wheel horizontal. Cool. So now we have all of these guys. We can just get the ones we don't have yet. And just paste them down here. End case. And right now we don't have them do anything, so we will just, pretty sure the AI can figure this out, but here's what we'll do. We'll copy this, go here, 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 here. Paste that. Change this to middle, right, X1, X2. And we can copy this, go here, 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 and here. Paste that. Go up 1, 2. Copy this. Go down 1, 2. Paste it. Okay. So that will set all of those. I'm going to move this to the top so these are a little bit more uniform down there. And then we're going to have two mouse event here, set scroll, and we're going to use the mouse X and the mouse Y and these guys too. Math max int 32. What? Scroll. We'll just use mouse Y. And this needs to be a float 32. Okay. Cool. Now we just actually have to fill out those inside of, or figure out what those are. So if I open up a new window here, I should still be printing out the numbers. Yep. Middle mouse is 1920. 1617 is the right mouse. 2324, 2324. So so 1920, 16, 17, 19, and 20. 16, 17, 19, and 20. Sixteen, 17, 19, 20. So 19 and 20 was the EVT middle mouse down, return EVT middle mouse up, turn EVT right mouse down, right mouse up. So those other two are for the X button, and you'll notice how they overlapped, and that's just because there is a flag instead of the Win32 library that deals with those, which we didn't mess with here. So you'll see there's a flag here for telling whether it's the first or second button. And what we'll want to do is go inside of windowing H, and we have this Win32 mouse X button here. And so we're going to copy that over to our shared mem mouse X button there, and we're just going to put a 0 or 1 into that field. So back in the Win32.h, we'll say the mouse button is I don't care. We can set this all the time. It doesn't matter because we have the left and the L button stuff going on. So I don't care that if we're setting it all the time, but we can just say X button is this. If that's true, if this is greater than 0, return button 1, else 0. Maybe make this prettier later, and 0. Return 2, otherwise 0. That's not going to work because they're going to override each other. So I can just say if this x and 32tx btn is equal to 0. Here we're going to say X button is 1. Okay. And this is going to be the case for WM underscore X button down, I think it is. Here, let's see. I can look up these. Okay, it looks like it's NC X button. I don't know what the NC stands for. The non-client area. No, we don't want the non-client area. So we want, yeah, it's X button down. X button down, and we want X button up. I'm just copying these from our from the documentation. So I'm going to move this up, and like I said, I don't care if we call this multiple times. It's not going to hurt anything. Although doing these if statements on every click, whatever, it's not that bad. If it's a problem, when we measure, then we improve. That's the way to look at it. So we're going to do right, left, and I think it's just M for middle. Let me check. Yeah, it's just M for middle. So there we go. We've got left, middle. Let's do this in the same order. Right. Let's move mouse move at the top. And then after right, we have the X buttons. Cool. And now the XBTN is no longer going to be XBTN. It's going to be IE dot mouse X button. Okay. And now we have that mouse X button coming across over here because we're just casting the object. And now what did I say? I think it's 523 and 524. So let's go to Win32. In the case of 523, return those, but it's going to be different. We're going to say if oh, we're not getting that metadata in here, so we're going to just return mouse x1 and the mouse x1, and then upon mouse x1, we're going to determine which one we should be using. Let's go back to window go, and so if it is x1, we're going to say if, actually we're going to get the mouse event. It's mouse down, x1, mouse 1. Okay, so if me.x button is equal to 1, I'm going to do this one. Else if it is equal to 2, we're going to do x button 2. Same thing here. That means we can get rid of those there. And instead of having, we'll leave x1 and x2. Yeah, I shouldn't delete the x2 stuff because on other platforms we might get a separate event for x1 and x2. So we'll leave those where they stand. And if we're going to change this to say if it is that, otherwise we're always going to do this just because other platforms we may not even set the X button value in the mouse event input. Cool. So that should give us all that we need there, and that should set up all of our fancy buttons. Now we just need a build. Make sure it runs. Make sure we don't crash when we click all the buttons. Mouse move. Click on all the buttons. Cool. Still working. Still closing. Okay, so that's it for the mouse input, and that kind of lays the groundwork for some of the stuff we'll do for the keyboard input. Like I said, this could probably be better streamlined. It can use some kind of mapping. Could be mapped from C. But for now, we're just going to keep it nice and simple and straightforward. Just type in the numbers here, and we will deal with beautification later.